Hello everyone, it's Wilson here. Today let's talk about finding the inverse of the matrix A. This is the matrix A. It's a 2x2 matrix, and so we are going to use two ways in this video to find its inverse. The first way is that we are going to use the idea that when we adjoin the identity matrix to the right side of this matrix A here, and then what we do is that we are going to try to perform row operations on this matrix, and what happens is that we try to turn the left side, this A, into the identity matrix. If it's possible, then A has an inverse, and so the inverse would actually show up on the right side here. So let me just highlight this matrix. This is our final answer. So now that is one way to do it. The other way is that we are going to use a formula. Okay, so there is a really simple formula for finding the inverse. So let's say if A is equal to, since we're talking about a 2x2 matrix, if we have A, B, C, D for the matrix A, then the inverse, if the inverse exists, is equal to 1 over the determinant of A, and then multiply by the matrix. And this one, it's actually still coming from those entries right here. So we actually switch the A and D. So now the D takes the place of the A, and then the A takes the place of the D. Then what happens is that we are going to negate the B and the C. So that is the formula that we can use. And as you can see here, if the determinant is non-zero, then the inverse would exist. Otherwise, the inverse does not exist, and then A would be said to be a singular matrix. Okay, so we are going to use both ways to do it. Now, first way is that we are going to create the augmented matrix using the A here, and then the identity matrix, right? So we have 2, 1, and then -3, and then 4. And then now put the identity matrix on the right side. So now we have A here, and then the I here. And so we can start performing row operations right here. So the idea is that we try to get this into I, right? So we actually need this number to be a 1, and there are different ways to do it. One way is to simply just multiply the first row by 1/2, but if possible, we try to avoid dealing fractions too early. So in this case, what we can do is that we can take this 2 and then add to the second row, so that we can actually change it into a -1. So that's what we can do. So we can do row 1, okay, plus row 2, and then change row 2. So that's our first row operation. And you can see that I'm not changing row 1, so I'm still just going to keep that, as you can see here. So now what happens is that take the 2, adding the -3. So we are going to get -1 here, and then 1 plus 4, we're going to get 5. And then what happens is that 1 plus 0, we're going to get 1. And then 0 plus 1, we are just still going to just get 1. So now we have this. And what we can do is that we can switch the first and the second row so that we have a -1 here. And then, of course, we can turn it into 1, right? So we can do row 1, switch with row 2. And so we are going to get -1, 5. Then 1, 1. Then here, the second row, just copy. Okay, and then now what really happens is that we are going to turn this into a positive 1, right? So we can do row 1. So we're going to get 1, -5, and then -1, -1, and then we have 2, 1, 1, 0. Okay, so next is that we are going to turn this 2 into a 0, so we can multiply row 1 by -2. So -2 times row 1, adding row 2, and then change row 2. So we are going to get, so let's just copy row 1 first. So we are going to get what? We are going to get 0 here, because multiply 1 by -2, we are going to get -2. So adding to the 2, we get 0. So now -5 times -2, we get positive 10 plus 1 is 11. And then now here, negative 1 times negative 2 is what? It's 2 plus 1 is 3. And then negative 1 times negative 2 is 2. 2 plus 0 is 2. So now we have this. And then all we need to do right now is turn this 11 into a 1 so that we are almost getting there to the identity matrix, right? So we have 1 over 11 times row 2. So we have 0, 1, and then now we do have to deal with fractions. So 3 over 11 and then 2 over 11. And then you may say, what about the first row? Just copy. Okay, so now one more thing here is that if we just do one more row operation and then turn this negative 5 into a 0, okay, then we are going to get the identity matrix on this side. So the right side will give us the inverse. So all we need to do is to multiply this by 5, right? So we do 5 row 2 plus row 1, change row 1. And then we are going to get, well, just copy the second row first. Okay, so multiply by 5, then we are going to get 0. Multiply this by 5, what do we get here? We get 15 over 11 and then minus 11 over 11. So we get what? 15 over 11 minus 11 over 11, 4 over 11 here. Okay. And then what about the other one? The other one is that multiply this by 5, right? So we get 10 over 11. 10 over 11 minus 11 over 11. So we are going to get negative 1 over 11. Okay, so what happens is that we have the answer. So our inverse of A is going to be just copy from this matrix right here. So 4 over 11, negative 1 over 11, 3 over 11, and then 2 over 11. If you want, you can actually factor out the 1 over 11. So we are going to get 1 over 11 on the outside. And then we will have integers inside the matrix. So we get 4, negative 1, and then 3, 2. And so that is the inverse of A. Okay, so that is our first way of finding the inverse. And then now using the formula, this formula actually comes from performing the row operations on this ABCD. But now we can just plug into the formula. This will be a lot quicker than doing row operations because the work has been done already. So now we are going to just do it here. So that's the second way. It's what? Well, first we need the determinant of A, right? So determinant of A, what is A? Well, A is 2, 1, negative 3, and 4. Okay, so what is the determinant? The determinant is actually the main diagonal entries multiplied together. So 2 times 4 and then minus the other diagonal entries multiplied together. So we have 1 times negative 3. Okay, and in fact, if you want the actual formula in here, so as you can see, this is A, this is B, this is C, this is D, right? So what really happens is that we are going to get AD minus BC. Okay, so that is the formula for that. So now what happens is that we are going to get 8 minus negative 3. So 8 plus 3, so we are going to get 11 as the determinant. Okay, so now going back to this, all we need to do is to just look at this matrix right here and then, well, let's copy down the formula first, right? So A inverse is equal to 1 over the determinant of A. And then now we have what? We are going to have D and then A, switching them, and then negative B, negative C. So all we need to do, okay, is to apply the formula. So we have the ABCD already. So A inverse is equal to, now we already got the determinant. So it's 1 over the determinant of A. So we are going to get 1 over 11. Okay. And then now what happens? The A and the D are switched, as you can see. So A was originally at the 1, 1 entry and the D is at the 2, 2 entry. Now they're switched. So we are going to get the 4 and then the 2. So you can see that they're switched. And then now negate the B and the C. So we are going to get negative 1 for the B, and then 3 for the C. And so that is our inverse. If you want, you can multiply the 1 over 11 inside the matrix. Okay, so that is the same answer as you can see, but this is a lot faster. Okay, so that's it for this problem. I will do more example next time. So thank you for watching this video.